Hello, everybody. Welcome to section 1.5, solving equations, part 2. So in part 1, we talked about quadratic equations and absolute value equations. So those are in part 1. And so we're going to talk about some different equations here in part 2. So first, let's talk about fractional equations. Everybody's favorite. So let's do an example to kind of see the technique. So let's solve 1 over x minus 1 over x minus 4 equals 1. So first, do in this case, the subtraction. So whatever this operation is, right? So that would look like 1 over x minus 1 over x minus 4, right? And so we want to get them over the same denominator. So we'll do 1 over x times x minus 4 over x minus 4 minus 1 over x minus 4 times x over x. That gets us x minus 4 over x minus 4 minus x over the same. And now they've got the same denominator, which is good. So now we can subtract. So we get x minus 4 minus x, because this minus sign distributes right up to there. And then we get x minus 4. And then if we simplify, these x's cancel out, and we get minus 4 over x minus 4. Cool. So second, we're going to multiply both sides by the denominator. So both sides by denominator. So right now our equation looks like this, because we did the subtraction equals 1. And so what we're going to do is we're going to multiply both sides by x minus 4, x minus 4. And the reason we're doing that is so now these cancel, right? And we get minus 4 equals 1 times x minus 4. And then what we're going to do is we're going to simplify this and solve the quadratic, right? So we get negative 4 equals, and then we get, so the 1 can kind of just go away, and then we distribute this x in. We get x squared from this first one minus 4x from this second one. And then we're going to make everything equal to 0 so that we can factor. So then if we add 4 to both sides, we get 0 equals x squared minus 4x plus 4. Now, you can factor this using the AC method. That's totally fine. Or you can note this is a perfect square. Right? So then we get 0 equals x minus 2, x minus 2, right? So now, if we apply the zero product property, in both cases, we get that x minus 2 equals 0, which implies that if we add 2 to both sides, x equals 2. So that would be our answer. So that is how you solve sort of a fractional equation like this, right? So first you do that operation, and then you multiply by the denominator on both sides, so you get rid of the whole fraction part of it. And then usually what will be left is some sort of polynomial, which then you can factor and solve for x using techniques we've already talked about. Cool. So the second kind of equation I want to talk about is equations with radicals. Right? So again, let's do an example to kind of see the technique. So let's solve for x. Let's do square root 2x plus 1 equals x. So first, we're going to move all the terms not under the radical to one side. So in this case, we've got this plus 1 over here, so we want to move that over by subtracting 1 from both sides. So we're going to get square root of 2x plus 1 equals x minus 1. Now, why do I want to do that? Because the second step is square both sides to get rid of the radical, right? So then we get 2x plus 1 in radical squared equals x minus 1 squared. So then we get 2x plus 1 equals, and then we can sort of FOIL this thing out right here, and what you'll find is you get x squared minus 2x plus 1. And then I'm going to solve this like a regular quadratic, so I'm going to move everything to one side, so get x squared minus, minus 4x, and then these ones cancel, so just get equal to 0. And then I'll pull a factor of x out, right? Because we've got one copy of x here and two copies of x here. So I'm going to pull a factor of x out, so I get x times x minus 4 equals 0. And then applying the zero product property, that gives me that x equals 0 or x equals 4, right? The x equals 4 came from this equaling 0. Now, warning. When you do this, you need to check your answers. By plugging back in. And we will see the reason why. So let's take one of these. So let's do for x equals 4, we're going to plug it back into our like original equation. So the left-hand side will be over here. Over here we'll do the right-hand side. And so if you remember from back all the way up here, this is what our equation looks like. So if we plug in 4 for x on the right-hand side, right, this is just x, so that goes to 4. And on the left-hand side, we've got this mess. So it starts with square root 2x plus 1 on the outside plus 1. So we plug in 4 for x, we get 2 times 4 plus 1 plus 1. Simplify this becomes 9 with the square root plus 1. We have 3 plus 1, and then we've got 4. So these match up. And that's good. That means that 4 is a legit answer. Now we need to check x equals 0. So for x equals 0, we'll do the same thing. We'll have right-hand side, left-hand side. So x, plug in 0, we just get 0. And if we start with this one, again, 2x plus 1 plus 1. Plug in 0, that gets us 2 times 0 plus 1 plus 1. That goes away, so we get square root of 1 plus 1, which is, sorry, getting ahead of myself here. 1 plus 1, which is 2. These do not match. See? So 0, not a legit answer, which is very sad. But this is the reason you need to check your answers, so you can actually find what works and what doesn't. So the solution for this equation with the radical is x equals 4. Cool. All right. Last one I'm going to talk to you about is equations with multiple variables. All right. And these are usually actually pretty straightforward, despite how scary they look sometimes. So solve for, and I'm gonna have solve for x here, but we could be solving for anything like a or q or t, whatever variable works. So let's say we have an equation like x minus 2xy over, like, I don't know, q equals 34 or something like that. So when we see something like this, what we want to do is we want to isolate x. We want x alone. So you just do what you need to do for that. So for this one, first what I'm going to do is I'm going to multiply q on both sides of the equation. So get that on top so that these cancel out, right? So then I get x minus 2xy equals 34q. And then I see that there is a copy of x in each of these terms, which means I can pull them out in front. So I get x, and then there's secretly 1 here, minus 2y equals 34q. And then I will just divide both sides by 1 minus 2y, like so. So then these will cancel, and I get x equals 34q over 1 minus 2y. Now this is messy, right? But we got x alone, right? But it's okay, because we wanted to solve for x, we did. And yeah, we didn't get a number out, but that's totally fine. We just wanted to know what this equation looks like when we have it in terms of, you know, x. Cool. So these are like the basic techniques we'll be using for the rest of the course to solve whatever problems we're doing. So keep at it and good luck on the homework.